So, good afternoon to everyone. Today, I'd like to discuss something about the concurrency. Basic point of concurrency is why we require concurrency. That is the point actually. So, reasons to have the concurrency. Yesterday, what are the basic differences? What are the basic differences between concurrent kind of processes and sequential kind of process? These two have been discussed in the previous class or previous session. Today, we'd like to take into consideration that why concurrency. Concurrency will be required for what purpose? Let us see. Let us see and have a small discussion today. Look at this. So normally concurrency is a very natural, general phenomena. It is a general phenomena in terms of the real world. You can see, I'd like to have some kind of photographs for you, small designs for you. So look at this, the national highways or super highways, international highways. You can see these. Normally concurrency is being happening here continuously. So using a single road in the sense the road might be having any width, whatever the width it might be, is in single road, many number of vehicles will be passed by. Vehicles will be passed by. And one more scenario when something like that, Chaurasta will be available here, something like this, how this could be gets managed. It also comes under the concurrency. Not only this one, so while a college will be gets open and people are occupying the seats by enter into the classroom. Before going to enter into the classroom, same staircases will be used by many number of people. That also will become under concurrency, and how this concurrency will be managed. That is the biggest point, biggest issue to be considered. Okay. And there are what is the basic principle to be taken into consideration while the concurrency is being taken into consideration here is when we are trying to design and monitor and control the real world systems, we must deal with the natural concurrency where exactly available in the real world. Okay, it must be taken into consideration. So while by tomorrow onwards, technically we'll speak very clearly. By tomorrow onwards, technically we'll speak very clearly. Today and yesterday, something like what do you call a theoretical subject, something like that. Okay, by tomorrow onwards, we'll speak very much technically. Don't worry. Okay. Then how this could be implemented? Before going to implementation of these, we must take care about. So we must take care about these systems first. These systems first. Okay. Then when dealing with the concurrency, so we have two basic fundamental aspects to be answered. Two basic and fundamental aspects to be answered. Number one. So detect the occurrence of random order, detect the events which are being occurred at random order. So there might be having some kind of a probability to have events could occur or could not occur. So if everything will be get smooth, there is no event actually. There is no collision, there is no occurrence, everything is not supposed to be there. But if you are talking something about the event, that event might be many number of events are there. If you take this particular scenario, event will be if this car and this car will be maintaining same speed in the sense they will be go in beside some there might be having some any stone will be there somewhere else here. Obviously, it could be get punctured, then accident will be gets happen. Accident will be gets happen. How this could be managed? How this could be managed? That is what the accident will be considered as an event. I'm talking very generally, very precisely and generally. Okay. So then if you consider this particular scenario, so here some chaurasta will be available. So while moving, the vehicles right away from all four roads, how they could be take their own way after reaching to the Chaurasta here. How this could be? It's also one of the biggest challenge, and this could be one of the events. Likewise, you could see in our daily life, you could see many number of events while many people are doing same work. Many people are doing same work. You can see these kind of events. Okay, and these kind of events will be happened at random order, not exactly the same time, at random order. So when such kind of event will be gets happen, so how could you detect them? Detection of those events is one of the challenge. And after detection, how could you respond? After detection, immediately you have to answer. How could you respond? If you are not supposed to respond, things will not be good. Okay, this is the first point, or first kind of thing which we have to take into consideration while concurrency will be implemented by you by using any kind of software. So you can take any kind of software by using any kind of software. So you have to answer for this one first. Then followed by second one is yes, detection is gets over. The detection is gets over, and an event was occurred in any somewhere else in the software. So how fast you can respond? How fast you can respond? That is also one of the very important aspect to be considered by concurrent systems. You can see. So how fast? What is the interval while an event will be gets occurred for a response? So how fast you are respond? These two are very fundamental kind of issues to be considered when concurrency will be taken into consideration. Okay, so these are very important. Okay, you need to remember these two. Of course, many other are there. Many other while implementing the concurrent systems, many other are there. If common variable will be there, for example, how can you manage to update that common variable? What are the scenarios you have to follow? And the common memory will be there for many number of CPUs. Then how can you manage that particular memory? So number of CPUs are some 20, and amount of space which you have with you is some 20 MB. Then how could you manage? How could you manage this particular 20 MB among all 20 systems, 20 CPUs? How could you manage? And only one printer will be there with you in your total network. Then how could you manage to get the printout of many number of people? All these things are challenges of concurrency. All these things are solution must be given to everything, and these solutions will be, so while giving solutions, what kind of problems you are supposed to face will be a very big challenge to be resolved. Okay, then if concurrent activity will be evaluated independently, then there might be having some kind of activity you have to do. What is the activity in the sense? For one kind of problem, one simple thread will be written by you. Thread in the sense of program or thread you have to written. When such kind of event will be, such kind of activity will be done, occur immediately. You have to respond with the activating, with the executing so-called program which was designed by you to resolve the problem of that particular event, that particular activity. Something like that you have to perform. Okay. So then challenges. What are the challenges to be done here in the sense? Most of the challenges will be always comes with one particular point, that is interaction. That is interaction. While interacting one CPU with another CPU, then problems will be raised. What are the problems? Let me explain. That list also be there within our presentation. So I'd like to explain that. So interaction in the sense, one CPU, one particular CPU does have Pentium 4, for example, Pentium 4. So another CPU might be Core i3, Core i3. For example, these two are there with us. Pentium 4 CPU speed will be very low. Okay, Okay, very low when compared to this particular Core i3. This is very high, too much high when compared to this particular Pentium 4. While Pentium 4 is, Pentium 4 requires some kind of data from the Core i3 system where the user has used, then Pentium 4 is being communicated. Yes, that communication, that requisition has been taken by this Core i3, so by from Pentium 4, yes, it has been taken. Then he wants to have some kind of data from Core i3 system to so Pentium core system in contrast. Then you can see so the buffer size, the receiving buffer size of Pentium 4 will be so very small. Let me say that is 1 MB. For example, I don't know whether it's correct or not. So time being, for example, I'm explaining. And the Core i3's so size of this particular buffer, okay, network buffer will be, so let me say 1 gigabyte, for example. Okay, 10 MB, simply speaking, for simplicity, so we'd like to specify this is 10 MB because for explanation point of view, we'd like to take 10 MB. Okay, so the buffer size of Core i3 is very high when compared to Pentium 4. Now it has been made one particular request. So a request has been made by so this particular system. Which one? Pentium 4 to Core i3. Yes, Core i3 is agreed to send the data. So it agreed to send data back to this particular system. But what is the basic bottleneck here? What is the basic problem here? So receiving buffer size is 1 MB, while so enforcing or let me say throwing buffer size is very high. So if you want to receive the data from Core i3 to Pentium 4 at this particular point, so the Core i3 data must be divided into 10 different pieces. So piece 1, this is 1 MB of this one. So again, one more piece, this is 1 more MB. Something like this, you have to divide it into so 10 pieces. So each and every piece will be sent to that particular. So this dividing of data into number of pieces and whether they can be sent properly or not, whether everything has been received or not, everything could be looked forward by Core i3 only. It is not the responsibility of Pentium 4. Yes, the data has been requested to you, then immediately it has been agreed. So acknowledgement, this is called as ACK. Acknowledgement has been given. Yes, I am going to send the data to you. So then the problem is raised here. So this is the information. What about one of the informations? What about the interaction is? Okay, interaction is. This is the problem. So in this way, you are supposed to take into considerations while so concurrent programs are being so communicate together. Okay, it is one of the examples. Such ways, many number of examples are there. We will discuss in future. Probably while progressively course is being going on, then we will discuss completely what are there. Then, so if you consider vehicle traffic diagram, just I have given just before in the slide. It is a good analogy for concurrency. Analogy in the sense you will get a proper idea how you have to implement that concurrency. Very good analogy. Okay. Then followed by so parallel traffic in the sense parallel traffic will be done. So parallel traffic in the sense the traffic will be happen something like this. One vehicle is going here, and in another road one more vehicle is going here. So something like this will be called as a parallel. So it could be okay. It could be okay. But any interaction will be done. Any interaction in the sense collisions. So after some time, so it is going in parallel, but after some time, so such kind of collisions will be done at this moment. It will be gives you, or it will be causes you huge, not exactly few, huge problems. Very huge problems are being generated. Okay. So why it could be taken? The traffic analogy will be taken into consideration. So interaction might be in many ways while you are driving any car or two-wheeler or truck, anything. Interactions will be like many ways. So one of those interaction will be so colliding to each other, So intentionally, they maybe interact with you. Otherwise, some brake failure. Otherwise, some puncture will be gets happened. Something like that. Everything. So you have to identify what kind of thing or what kind of event which was occurred at that particular point while interacting with the two processes. So it must be always taken into consideration. Okay. Then parallel streams or adjacent lens required to coordinate for safe interaction. Okay, so adjacent lens in the sense there might be having some mirror outside of your vehicle. Otherwise, in two wheelers also we do have some mirrors. So you have to look forward to that particular mirror continuously while you are taking your journey. Okay, if any vehicle is followed you, or if any other vehicle is come, more speeder than you, then obviously, so you may be take care about it. So, how you can take such kind of safety measures while developing any kind of software using this concurrency technique. So here for traffic analogy, so some lenses will be there, so mirrors will be there. These mirrors are very much useful to you to so take some diversion, take some kind of other activities, something like that. So how could you take such kind of safety measures while so implementing any kind of concurrency control kind of systems? Okay, so that is why this traffic is very good analogy for us to explain that. that. So there are many reasons to be inspired to be specified here. Number one, first one is so concurrency will be always done while parallel execution of processes will be gets happen. Okay, concurrency does also means that parallel execution of so-called number of processes at a time. Okay, so that is called as concurrency here. So it is very much interest to perform such kind of operation. So there are several different types of specifications here. First specification, one of those parallel execution specification might be if you have multiple CPUs, and you can perform the operations separately. Let me give you one specific example at this moment. That example is so there are several number of elements which are available with you. Huge number of elements are there with you. So 2 power 100 number of elements are there with you. Okay, for example, it could be considered as the telephone directory of this country, for example, and wanted to sort this particular list of elements. So what exactly we are trying to do using divide and conquer? You have to divide this list into exactly half. So here it is 2 power 50. Here it is 2 power 50, for example. Not example, exactly 2 power 50, 2 power 50. Okay. So 2 power 50, 2 power 50 is very huge enough. So then again, you have to divide into some more here, some more here. Now it is 2 power 25. Then here it is 2 power 25. And here also same. 2 power 25 also very big. So therefore, you have to divide it into 2 power 12. So this is 2 power 13. Now, again you have to divide it into 2 power 12. So 2 power 13, something like this. Then if you run this particular problem separately in CPU1, and this particular problem will be run in CPU2, this particular problem. So after dividing this one, this particular problem will be run at the CPU3, and this particular problem will be run at CPU4, and so on and so forth. So what is the actual problem here? Sorting given list of elements. Okay, sorting the telephone directory across the country. That is the operation. So CPU1 will be done 2 power 12 separately. Again 2 power 13 will be done by another CPU, and so on and so forth. After completion of, because all CPUs may get same number of elements. There is no difference at all. Same number of elements are being taken by each and every CPU. So to completion, for completion of the sorting with each CPU will be taken same amount of time. After completion of that particular amount of time, everything will be merged together. Then you could get the answer very easily with very, very less time. With very, very, very less time. So that is why if you have multiple CPUs are available with you, then it could be parallel execution of so-called problem or so-called process will be very easy to perform. Whereas if the same operation, 2 core 100 number of records are there with you, if the same operation will be done by you with a sequential CPU in the sense only one CPU will be there and operations will be done at sequential manner. If you want to perform this one, you must wait a huge amount of time, very huge amount of time. So that is why. So there are what are the reasons to be implement this concurrency here in the sense. This is the reason where exactly it is being gets implemented. Okay. Then hope that you got the point. I think. Then, so that is the meaning of these two here. Okay. Then sometimes it could also be. So same thing will be also done by single processor with multitasking system. Single processor with the multitasking. All Windows machines, all Windows desktop or laptop machines are single processor, and they will perform multiple tasks at the same time. How they could be done? So they could be always interleaving fashion. Interleaving fashion here in the sense it could be done something like this. So one process will be get started here, and after some time, one more highest priority. So priority of this one will be, for example, P1. The priority will be P1. So it could be get P sub 10 will be get started here. Then the one more process will be gets into ready queue for execution, which does have so P9 as a priority. Obviously, it could be interleave and P2 sorry P9 will be took place. After execution of some time, one more process will be enter into ready queue for execution, whose priority will be sub 2. So then immediately P9, priority, having priority 9 of this particular process also be so exited from this one, and P2 is going to be so executed. In this way, the execution will be happen in the what you call uh, 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 interleaving fashion. Since it does have interleaving fashion, some 50 to 40 to 50% of concurrency will be also gets happen in single processor multitasking system. It could be happen. It could be happen. But a pure concurrency cannot be happen while we are talking something about so single user system here. Okay, single user system here. Normally, these kind of systems will be, these kind of issues will be available in any kind of system, whatever the system it might be, while it is being get startup, then everything will be seen. Everything will be seen. So sometimes one particular system will be taken huge amount of time to start. Some other system will be taken very less amount of time because Core i3 will be taken some 35 seconds to start up, whereas Core i5 will be taken some 25 seconds. Core i7 will be taken so 11 to 15 seconds, something like that. Because if you increase the number of cores in our system, obviously the number of processes which have been executed by each core will be gets increased. Okay, so that is the point I'd like to make here. That. So when concurrency will be implemented by you, so there are several number of components which are being taken into consideration. First and the foremost component is CPU cycles. CPU cycles. CPU cycles are very, very, very important. Then followed by second component will be memory. Memory in the sense, so that is random access memory. Okay. The third component which is required by you is so the system bus. The system bus also playing a vital role while taking this particular thing. Okay. Okay. So something like that. Many number of other components also required for you to get the operation. Okay. Then followed by So, if you want to perform the same kind of operations by using sequential manner, it's very painful to operate. So, because you have to execute or you have to write huge number of lines of code to implement the same thing in sequential manner. Okay. So, if you want to perform, this is actually not exactly the point which I would like to make at this moment, but of course, while running with the concurrent systems, the same operation will be achieved by sequential systems in the sense, of course, it could be achieved, but time to be taken to achieve that particular operation will be very high, very, very, very high. Okay. Then controllability. There is a particular property of the concurrency that is a controllability. While so everything what I am supposed to discuss at this moment, every operation will be discussed with you in the nearer future. Probably in race condition, probably in synchronization, probably in message passing, everywhere else. We'd like to discuss everything. Okay, controllability of processes, controllability of resources, controllability of sharing, controllability of memory will be enhances for concurrency. Okay, so these are the reasons why the concurrency is required. These are the basic reasons why concurrency is required here. So I'd like to stop at this place and let me give you by Monday the race condition in different scenarios, not exactly one scenario. I'd like to give you an operating system point of view. I'd like to give you a network point of view. I'd like to give you a database management system point of view, and also like to give you in thread point of view. In four different situations, how race condition will be, how race condition will be gets happen. I'd like to give you when in examinations anything will be asked regarding to race condition. All these four are required: the operating system point of view, database management system point of view, network based system point of view, and then followed by threat point of view. All these four are required. All these four are required here. So therefore, we would like to consider this particular race condition by next class with these four different types of scenarios. Okay. Don't go away. I'd like to take attendance of you. I'd like to take attendance of you. So totally 22 people are attended. Thank you. Thank you for